Hello everyone. In our earlier video, we have seen electric field at a point on the axis of a dipole. Now, in this video, let us derive an expression for the electric field at a point on the equatorial plane of a dipole. We have seen earlier in the previous video what is a dipole. A dipole is two equal and opposite charges plus q and minus q separated by a distance 2a. So the line passing through both the charges is called as axial line. We have seen it in the previous video. Now in this video we will see the electric field on the equatorial plane. Equatorial plane means the plane passing through the center of the dipole. So, and perpendicular to that. It is a plane perpendicular to the axis of the dipole and exactly passing through the center of the dipole. Now, let us derive the expression for that. Let us see the figure for the derivation. Now, look at this figure. In this figure, a dipole is placed between AB. At A, we have positive charge. At B, we have negative charge. O is the center of the dipole. OP is perpendicular to the axis of the dipole. And the plane passing through OP, which I have not shown here. But if you can imagine a plane passing through OP and perpendicular to the axis of the dipole, that is called as the equatorial plane. Now we have taken a point P on the equatorial line, or we can also say it is a point P lying in the equatorial plane. Now our derivation is to find the expression for the electric field or at a point on the equatorial line. Now as we know, plus Q is placed at A, minus Q is placed at B. The length of the dipole is 2a, that is AB is equal to 2a. O is a midpoint of the dipole. Point P lies at a distance r from the center of the dipole O. Once again I repeat, point P lies at a distance r from the center of the dipole O. OP is perpendicular to AB now. Now, dipole moment, as we have defined earlier, dipole moment is a vector, that is the product of q and 2a. Its direction is always from negative to positive, that is minus q to plus q is called as the direction of the dipole moment. You can see it in the bottom of the figure. Now coming to the electric field, as I have told you in my earlier video of this dipole, for a positive charge, the direction of the electric field is always outwards. For a negative charge, the direction of the electric field is always inwards. Therefore, plus Q is placed at A. Therefore, electric field due to Q is outwards. Therefore, the arrow goes outside from A to P and then it goes outside. That is shown as E plus Q bar. E plus Q bar is the direction of the electric field due to the positive charge plus Q. Now, if we see the direction of the electric field due to the negative charge, E minus Q bar, that is along PB. Because Q minus Q, that is which is placed at B, is a negative charge. Therefore, the direction of the electric field due to negative charge is towards B. Therefore, E minus Q is shown as an arrow is shown towards the point B. Now if we see E plus Q is in that direction along AP, E minus Q is in the direction of PB. Now, if we take the components of the vector or resolution of vectors, E plus Q will have two components, that is E cos theta along x direction, positive x direction, and E sin theta along positive y direction. Once again, I repeat, if you take the components of E plus Q, E cos theta is along positive x direction, E sin theta is along positive y direction. At the same time, if we take the components of E minus Q, that is resolution of vectors, the components of E minus Q, E cos theta is along positive x axis and E sin theta is along negative y axis. This is to be noted now. E cos theta is along positive x axis and E sin theta is along negative y axis. Therefore, sin theta components of positive charge and negative charge, they cancel out each other. So if you can see, what happens here is, first let us take as the equation of the electric field E plus Q is equal to Q by 4 pi epsilon naught into 1 by distance square. From positive charge, the distance is AP. Therefore, 1 by 4 pi epsilon naught Q by AP square. But as per the Pythagoras theorem, AP square is equal to AO square plus PO square. Therefore, E plus Q is equal to Q by 4 pi epsilon naught 1 by R square plus A square. Since AO is equal to small a and PO is equal to small r. Let it be equation number 1. Similarly, the same thing applies to negative charge also. E minus Q is equal to Q by 4 pi epsilon naught 1 by R square plus A square. Here we have written only magnitudes because we have to find the resolution of vectors as I told you earlier. So these are the equations for electric field due to the positive charge and electric field due to the negative charge. Now, if we see, once again, I repeat, E sin theta components of positive charge and a negative charge, one is vertically upward, other is vertically downward. That is positive y direction and a negative y direction. So, sin theta components of E plus Q and E minus Q, they cancel out each other. And what remains is E cos theta due to positive charge and E cos theta due to negative charge. Therefore, we have to take cos theta components only into consideration. Once again, I repeat, according to the resolution of vectors, E sin theta of positive charge, which is in the positive y direction, and E sin theta because of negative charge, that is in the negative y direction, they cancel out each other, but the cos theta components of both the charges will be added together now. Now let us take the final expression. Total electric field due to the dipole is equal to E cos theta of positive charge plus E cos theta of negative charge. Therefore, cos theta we have taken common out. We have taken E plus Q plus E minus Q within the bracket. In front of the bracket, we kept a minus sign. Most of the children get doubt why there is a minus sign. Because already we have seen the direction of the dipole is from negative to positive. That is minus Q to plus Q. Here, E cos theta component is from our left to right. Direction of the dipole moment is from our right to left. Once again, I repeat, dipole direction is from our right to left. E cos theta components are from our left to right. Hence, the direction of the electric field is opposite to the direction of the dipole moment. Therefore, we have taken a minus sign in equation 3. Now, substituting the values of 1 and 2 in equation 3, which we have seen earlier, then adding both of them, we will get minus 2 by 4 pi epsilon naught q by r square plus a square into cos theta into p cap. As we all know what is p cap, which we have seen in the earlier video also, p cap is a unit vector along the direction of the dipole moment. Now, if you look at the triangle AOP, cos theta is equal to adjacent side by hypotenuse, that is AO by AP. AO means half of the dipole, which is A. AP, according to Pythagoras theorem, under root r square plus a square. Therefore, cos theta is equal to A by under root r square plus a square, which is equation number 5. Now let us substitute equation 5 in equation 4. Therefore, minus 2 by 4 pi epsilon naught, that is E is equal to minus 2 by 4 pi epsilon naught q by r square plus a square. In place of cos theta, we have substituted a by under root r square plus a square. Root means to the power of half. We all know that. Therefore, we will get minus 2 by 4 by epsilon naught q by r square plus a square, a by r square plus a square to the power of half into p cap. Now, we have to add the powers in the denominator. R square plus a square to the power of 1, r square plus a square to the power of half. Therefore, r square plus a square to the power of 1 plus half, which is equal to 3 by 2. R square plus a square to the power of 1, r square plus a square to the power of half. Therefore, r square plus a square to the power of 3 by 2. Therefore, we will get E is equal to minus q by 4 pi epsilon naught 2a by r square plus a square to the power of 3 by 2. The front 2 I have taken to the back side. And don't cancel 2 with 4, that is numerator and denominator don't cancel 2 and 4, because we need to keep it like that. Why we need to keep it like that is because we know q into 2a is dipole moment. Therefore, to get the dipole moment, we are keeping 2a as it is and then multiplying with the q, we will get q into 2a is dipole moment, which is p bar. Therefore, let us substitute it in this equation. Dipole moment q into 2a is equal to p bar. Therefore, E bar is equal to minus p bar whole divided by 4 pi epsilon naught r square plus a square to the power of 3 by 2. Now, as I have told in my earlier video also, dipole is nothing but a small molecule where positive charge goes one side and the negative charge goes to the other side. But the molecule is too small. Therefore, the distance between positive charge and the negative charge is too small, which can be neglected. Therefore, remove a from this expression, then you will get minus p divided by 4 pi epsilon naught r square whole to the power of 3 by 2. But r square to the power of 3 by 2, 2 and 2 will cancel, that will become r cube. Therefore, you can see here the final expression of the electric field is equal to minus p bar divided by 4 pi epsilon naught r cube. Once again, I repeat, the electric field due to a dipole on its equatorial plane, that is electric field at a point on the equatorial plane of a dipole, E bar is equal to minus p bar divided by 4 pi epsilon naught r cube. So earlier we have derived the expression for the axial line. There we got e bar is equal to 2p by 4 pi epsilon naught r cube. There we got in axial line the expression was e bar is equal to 2p bar by 4 pi epsilon naught r cube. What is the conclusion here? The conclusion is the electric field on the axial line of a dipole is twice that of on the equatorial line. So the conclusion is the electric field at a point on the equatorial plane of a dipole is double to that of the equatorial line. Thank you for watching my video, and let us meet again with another video. Until then, bye. See you all in the next video.